Hello and welcome to a new section, Naive Bayes. In this section we'll introduce another family of classifiers called naive Bayes. First, we'll introduce Bayes' theorem. Next, we'll compare generative and discriminative models. We'll discuss naive Bayes and its assumptions and examine its common variants. Finally, we'll fit a model using Scikit-learn. Now we move on to the first video of this section that deals with Bayes' theorem. In this video, we're going to take a look at Bayes' theorem and how it works. We'll apply it to an example of finding out the probability that a patient has a disease given that his diagnosis is positive. Bayes' theorem is a formula for calculating the probability of an event using prior knowledge of related conditions. Bayes' theorem is given by this formula. Let's work through an example. Assume that a patient exhibits a symptom of a particular disease, and that a doctor administers a test for that disease. This test has been found to have a 99% recall and 98% specificity. Specificity measures the true negative rate or the proportion of truly negative instances that were predicted to be negative. 99% recall means that 99% of the patients who truly have the disease were predicted to have it. 98% specificity means that 98% of the patients who truly do not have the disease were predicted not to have it. Also assume that the disease is rare. The probability that a person in the population has it is only 0.2%. If the patient's test result is positive, what is the probability that she actually has the disease? More formally, what is the conditional probability of having the disease, A, given a positive test result, B? We can solve this using Bayes' theorem if we know the values of the terms P of A, P of B, and P of B given A. P of A is the probability of having the disease, which we know to be 0.2%. P of B given A, or the probability of a positive test result given that the patient has the disease, is the test's recall, 0.99. The last term we require is P of B, the probability of a positive test result. This is equal to the sum of the probabilities of true and false positive results. The probability of a positive test result, given that the patient has the disease, is equal to the test's recall, 0.99. The probability of this outcome is the product of the test's recall and the probability of having the disease, 0.002. The probability of a positive test result, given that the patient does not have the disease, is the complement of the test's specificity, or 0.02. The probability of this outcome is the product of the complement of the test's specificity, 0.02, and the complement of the probability of having the disease, 0.998. This is Bayes' theorem, rewritten in terms of our events. We've solved for all of the terms, and can now solve for the conditional probability of having the disease given a positive test result. The probability that a patient who tests positive truly has the disease is less than 10%. This result may seem incorrect. Good. With this, we reach the end of this video. We learned about Bayes' theorem.